Today's objective is I can describe the ASCII encoding scheme. This is one of those lessons that was a huge aha moment for me when I was learning about computer science. You have this picture of someone saying UTF-8, EBCDIC is here, ASCII. This thing called an encoding scheme, in my mind, once I realized that everything in computers are encoded one way or the other, that's when I really started to understand how everything is working. Unless you're holding a printed copy of this article, you're reading this online inside a web browser. That means your favorite browser has used the HTTP protocol and others to syndicate and make the content appear on your monitor. HTTP stands for Hypertext Transfer Protocol. It's based on the request response model. Remember when you guys created a request and response messaging system using binary? So that's what this HTTP is based on. That same kind of idea, just like any other client-server specific application model. So why am I talking about HTTP and protocols when the lesson's supposed to be about ASCII and encoding? Well, that's because protocols use encodings. Now, protocols use other protocols to do things, right? And then that can be really confusing just looking at this table. But the ASCII part, the use of encodings from a protocol, is just much simpler. So here's the best way I like to explain it. If you've ever played the video game Portal, or Portal 2, there's this scene when the guy wakes up and the robot says, most test subjects do experience some cognitive deterioration after a few months in suspension. Now, you've been under for quite a lot longer, and it's not out of the question that you might have a very minor case of severe brain damage. But don't be alarmed, all right? Although if you do feel alarmed, try to hold on to that feeling, because that is the proper reaction to being told that you've got brain damage. So if you were to take your brain and think of it like a computer, so the brain knows the protocol when it needs to communicate, right? You talk and then someone else talks and you listen and then you get to talk again. So you take these turns, right? So the brain can still understand the protocol, but if the person goes to speak and does not put the right sounds in order to make words, then there's like a problem with the encoding. Since all information sent by a computer is encoded in bits, we need protocols to help us interpret these bits as meaningful information. So in previous lessons, we learned how to use binary number systems to allow us to represent just numbers in bits. Well, now we address the challenge of encoding text in bits, and find that we can reuse and build upon much of the work we did to encode numbers. This pattern of reusing solutions to other problems arises frequently in computer science and allows the development of more complex systems. I mean, that's why they're complex, because it's one solution is built on top of the other solution, and then again and again. So think right, share, if text can be encoded using bits, what else do you think in this world can be encoded to produce some sort of output? So ASCII encoding is a standard number-to-text encoding scheme used in computers and on the internet. This protocol is 7 bits long and so can encode 128 different symbols, each corresponding to one of the binary numbers between 0 and 27. So what that's saying is you have about 128 different reactions from the computer when you send it a number. For example, the number 65, when that binary value goes across the processor, 65 is the letter A, so the computer knows to display this letter A. Now that's going to be maybe a lowercase or uppercase, I forget which one, but that means you have 26 values for A through Z, and then you need another 26 for capital letters, and then of course all the other things that you can see on your keyboard. Those will need individual numbers as well. Think right, share, what is ASCII in your own words? So perhaps more remarkably, this printable character set is also used to represent all of the text formatting we use to add variety and emphasis to plain text documents. So what do I mean by formatting? I think this picture says it all. Formatting could be, bold. It could be blue or red or black, so different colors. You have italics. you have all the, all caps in a row, or whatever, capital letters and lowercase, and then fonts and such. So that's what formatting is. So pretty short lesson today, just trying to get you to wrap your mind around ASCII as an encoding scheme versus HTTP as this protocol for sending data back and forth. ASCII's using data to figure out what value, or what text, should be displayed on the computer screen. So a quick review of the vocabulary we talked about. Think, write, share. Just use each one in a sentence real quick so I can check that you're understanding how these words work. Some multiple choice practice here. How many bits are required to store the number 150 in ASCII? So quick binary practice. Number 2, you'll need to look up what's called an ASCII table to figure out what the right answer is. So it says the word apple translated into its ASCII number equivalent is what? Remember when I said 65 is the letter A? Okay. Great video if you have time in class today. This is from a YouTube channel called Computer File. They produce quite a few good videos. Basically, the guy talks about the Unicode consortium, talks about UTF-8, which is very similar to ASCII. However, apparently UTF-8 is becoming the dominant encoding scheme for English letters. There's an interesting part in the video when this guy's talking about the Japanese using 3 different types of encoding schemes for their language, and how their language is pretty unique, so it's going to be larger, which has some interesting, ramifications on the computer when the computer has to deal with larger encoding schemes. DOL for the day. Using vocabulary from this lesson, describe how the ASCII encoding scheme works with at least 2 specific examples.